When working in a typed language like C Sharp, where your variables have types, you're going to spend a lot of time creating and defining those types. So that's where we'll start here with the different ways that you can define a type. It includes classes, structs, and records. Before I do a couple things here, I have all of these different types in one code file, which isn't how you'd normally do that. I'm just doing it here to make it easy for us to see them all together. The other is you'll notice down here on line 12, I've got some squigglies under last name and on line 15 under first name. If I look at that, it's going to tell me that a non-nullable property must contain a non-null value when I exit a constructor. Now this is with Visual Studio 2022 using .NET 6 and C Sharp 10, and this is different if you're using a previous version. So this is a change that now enforces or provides some warnings around nullable reference types. We're going to talk about those a bit later. So for now, I'm going to right click and edit my project file. I'm just going to come in here where it says nullable and I'm going to disable that. I can save that file, close it, and then those things will go away and it'll stop warning me about that. So I'm back now to the behavior you'd see before using Visual Studio 2022, before .NET 6, in case you're using something that's a little bit older. And I'll try and show you throughout the course things that have changed, the various versions of C Sharp and other tools that we use. And what we've got here, starting on line 3, is a standard interface for an I person. It's got 4 properties on it: first name, last name, ID, and age. And those are using the auto-implemented property syntax, which means we'll have that backing field created for us. I'm going to use that interface. We'll start by looking at classes. When you define something as a class, you're defining it as a reference type, meaning that a variable that points to an instance of this class is pointing at a reference or is a reference to that instance. And so classes, as we can see, can implement an interface, the I person. I can also add other properties, as I've done here, starting on line 18, to that class. So if I'm treating it as an I person, that's my variable type, then I have access to those 4 properties from the interface. But if I'm working with it as an employee class, then I also have the additional properties there. And you can see starting on line 23, I have a manager class that derives from employee and can implement 0 or more interfaces. I can only have one base class, but any number of interfaces. So those are reference types, and those are probably the most common type used to date with C Sharp. We also have structs or value types. I've defined a struct here called age. It's got properties, the date of birth, and years old. And the difference here is this is a value type, meaning if I have a reference, I have a reference to the actual object. And we'll see shortly as we get into the ways that these different types behave, how that plays out when we're using variables, when we're copying, when we're passing things to and from methods. You can see on line 35, structs can also implement interfaces. So they can have properties, they can have methods, much like a class. And then in C Sharp 9, Microsoft introduced the notion of a record. So here I have a record called customer that implements I person, looks very much like a class, and in fact behaves in many ways like a class, but records are really intended for scenarios where you want to have immutable objects. They don't have to be immutable or unchangeable, but they can, and they're useful in scenarios where you're using it as maybe a data object. So you're passing it between service layers or between application layers, and it's primarily about creating an object with state and passing it around. You can see on line 51, records can have inheritance in this case. So I have a premier customer that derives from customer and adds the notion of a customer level. With C Sharp 10, it was released in the fall of 2021 with .NET 6, we also have the notion of a record struct. So here we have an order that has an order ID and an order date, and that is going to have the behaviors of a value type, like a struct, but also the behaviors and the capabilities of a record. Now, if I come down to the recurring order and I try and derive from, say, order, because I want to just add some functionality to With our types defined, we can start thinking about how other developers or ourselves are going to construct instances of these types. So we can start defining constructors for our classes. Go into my employee class here. I'm going to use a little keyboard shortcut, type in ctor and tab twice. Now I have a public employee, and I'll just add two parameters here, string first name, string last name. And then inside of the constructor, I can set the properties. So last name equals last name, and first name equals first name. And of course, confirmation that C# is case sensitive. We've got a property name that's different from our parameter name simply by the first letter. And that now allows me to create an employee, passing in the first name and last name, and initializing the object with that state. Your eye may have caught down here on line 28, though, that my manager class, which derives from employee, is now giving me a red squiggly, which will turn into a compiler error, that says there's no argument given that corresponds to the required formal parameter first name. Essentially, what this is telling me is, before I was using default constructors with empty parameter lists, but I don't see that here. So if I create a manager, how will I create the underlying employee? One way to fix that would be to come up here, use that ctor again. Now I have a employee default constructor in addition to the constructor that I've created. And now the compiler's happy because I can create a manager with no constructor or the default constructor, and it can then rely on the default constructor of the employee. Another way we could fix that, just comment this out for now, is I could come down to the manager. I can add a default constructor, and I can add those same parameters here, or I can indicate that I want to go to the base and I want to put some values into those parameters. These aren't very useful parameters. So it fixes the compiler issue, but as we all know, that doesn't mean our application works. It just means it compiles. So this is one way to do that, using the base method to call down into the constructor for the base class and pass in those parameters. Now, likely what you'd do is something like this, where you'd copy first name and last name. You'd use those as parameters here. And then when you call the base, now you can pass those in like so. So now we've got something that would actually work, would create us a manager, and on the base class, the employee would properly set the first and last name for us. So I'm going to pop out to our program.cs here. Let's add that into a new horizontal group. Let's get both of these on the screen at one time. Let's go back up. So we've got our employee. So if I want to create that employee, new employee, I've got the empty constructor. And that all seems to work until we pause and the compiler catches up and says, wait a minute, there is no default constructor. Once you've identified a custom constructor, the compiler doesn't automatically create that default or empty constructor for you. So this is invalid. So now I need to say first name and last name in my constructor. Then I can do a console write line. And I can say something like from. I can do e.firstname. Hello world, right? So now I can use that object that I've created and work through it. I can also change this to a manager. As a manager derives from employee. So I now have an employee variable that points to a manager. I've got the same constructor type defined on my manager, the first name and last name. So we're all good there in being able to create that instance, treat it like an employee. So if we use our IntelliSense, we'll see we've got start date and shift start time and all the employee properties, but we don't have the manager properties because, again, the variable is of type employee. That's how we're treating that variable. One last bit here. Let's go back up to our employee. What you may quickly find, if you're not already familiar with it from your programming experience, is that defining constructors that meet everyone's need can be kind of challenging. You add the parameters you think people will use, but it's not exactly what they want. Rather than creating 10 or 15 different constructor options, we can use these default parameters. And really, if we're going to do this correctly, we should probably make this the employee ID property on our employee instead of the ID. We'll just fix that while we're here. But we've got all these other properties. So we've got age, we've got the employee ID, start date, shift start time, all these different pieces. So one of the things we can use in C# is called object initialization. So rather than do the employee this way, I can come in and I can use curly braces rather than parentheses. And now I can put the property name in. So I can say first name equals Matt, last name equals Milner, and I can specify any of the properties that I could set on this object right here in this initializer. So I can do that employee ID. Let's say it's 75. Maybe we have that on hand. Maybe the start date equals new date only. We can pass in this year. Say they started in January. Another closing curly brace. And I've initialized that object, but it's giving me an error. And again, it's that one that's basically saying, well, look, I see you're trying to initialize all these things, but that means I need a default constructor. That's why I commented this out. Come back and uncomment it. So we have our default constructor, and that gives you a little clue about what's happening here. When we use the curly braces and we do the object initialization, the default constructor is going to get called, and we're then going to initialize or set all these other properties. So this is a shorthand syntax for us, makes it easy for us to create this all in one go. But it's very similar to creating the employee and then individually calling all of the property set methods on it. Just as an example, let's come in here then, and in the default constructor, we will set the ID equal to, let's say 5. And we come back out here. Let's go ahead and we'll say from that first name, employee ID. And so we'll do EID. And we probably shouldn't call it employee ID. That's confusing. We'll just call it ID. It's hello world. If we run this, it'll compile, it'll build our executable, it'll run our console application. You can see from Matt ID 5, hello world. So the default constructor gets called, and then our object initialization kicks in down here to set those other properties. You can mix and match the constructors and the initialization. So based on what we saw, this is the equivalent. We could also come in here and do Matt Milner 75. That's our constructor that takes those 3 items. We can get rid of this, but we can still initialize the start date with the initialization syntax. So you get the benefit of simplified constructor that maybe gets you most of the things you want to set, and the initialization syntax that allows you to set those additional properties all in one go there. We've been working with our employee, which of course is a class and a reference type. What about an age? What if we come into the age and we specify our default constructor? We get a little bit of a warning that says, this is okay, you can create a default constructor, but because this is a value type, you're going to have to assign a value to age, birth date, and age years old inside of here. So if we want to do that, we're going to have to come in here and say, all right, I want a date time, DOB, and I want an int years. And now I can come down. I can say birth date equal DOB, and I can say years old equal years. And that makes it happy. Because again, it's a value type. Once we get it created, we have a variable, then we're going to want to hold that value. And so when it gets created, we have to initialize those properties. Now for records, same thing. We can come in. We've talked about different ways to initialize your objects. I want to go back to our properties here. As we get into a pattern, much like you see here, where I have just an auto-implemented property with a get and a set. There are different options for what you do there. If we look at our Premier Customer, you can see I have a customer level and I have a get, but I also have an init, meaning this can only be set or the value changed when initialized. What that looks like is if I come down here, we try and create one of these. So I'll do Premier Customer equals a new Premier Customer. Notice I've got only an empty constructor. I can do first name equals new customer. And now if I try and do pcust customer level equals 2, say that's going to give me a value, I'm immediately getting compiler error warnings that say that's an init only property. You can only set that during initialization. So what does that mean? Well, I could just come in here and do a constructor that takes a byte. And that byte's going to be my level. So I could do byte level, and then I could set the customer level equals level in there. And now when I create that Premier Customer, I can pass in the 2. That's happy. And we could even do a write line. So we could say the pcust first name has level. Oops, missed our double quotes there. Got a little carried away. So we got pcust first name has level, pcust customer level. We've got that. So now again, if we run that, Control F5, skip the debugger to speed it up. You can see we've got new customer has level 2. So that's one way to do it, is to create the constructor. The other, of course, would be to continue to have a default constructor. Again, I've gotten rid of the default by creating a custom one. So I'll put the default back in, and I could change this now to use those, do customer level equals 2. And again, that makes it happy because I'm initializing the object and I'm setting that value. I'm just going to take that and copy it, and we'll put another one up here just so we can see both. We'll comment that one out for reference. So init only allows us to do that. Now another option, let's go up here back to our employee, for example. And I showed you the init on records because, as I mentioned, they're often used as immutable objects, and that's a way to do that. If you set your properties as init only, then you allow for that sort of a pattern where when you create the object, that's when you can set the state, and then after that, you can't change it. So we look at our manager, we've got this constructor here. Let's put a method on here. I'm just going to say public void set reports. It's going to take an int number of reports. And then I can come in and I can set number of direct reports equals number of reports. Now, in and of itself, this isn't very interesting. One of the things we can do is change that to a private set. So now I come out here into our program. I say I want to create a manager equals new manager. We got first name and last name. We'll give them something very original like manager boss. Now, if I try to set the number of direct reports, say they've got 7, I get an error. I can't use it because it's private. That means it can only be set from within that class. What I can do is I can call that method. So I can say set reports, pass the 7, and that's happy. So you can control the access or the accessibility of the get and set, or use the init to change which pieces of your code have the ability to modify that state in your objects. Let's look at how these different types work. So reference types or classes, structs, value types, and then the records. I've got a method here, just back out of my program.cs called classes, and I'm going to create an employee. I'm going to initialize it. So I've got a name. Notice the age here, got a birth date back in 1971, means 50 years old with an ID of 1. And then here's where we start working with those reference types. So on line 22, I define another variable called other, and I set it equal to me. Then I change the first name and the age on the other variable. Now what's going to get written out here on line 27 if I write out me dot first name and age years old, as well as other first name and age years old? So think about what's the original variable me and what's happened now that I have another reference, this other, that points to it. So let's run that quick. See if you got it right. Let's look at the first couple lines here. It says Bizarro Matt is 39, but Bizarro Matt is 39. So because it's a reference type, this other variable that we created is still pointing at the same memory. It's still pointing at the same object as me. So when I make changes to it, like the first name and the age, I'm changing one single object, even though me and other both point to it. So that's a reference type. Now, I've probably given this next bit away. The other thing we're going to do then is pass this reference type into a method and manipulate it in there. So I have this method called change name. I'm going to call that, passing in other, that second reference. And then afterwards, I'm going to print out first name, last name, and how many years old. So in the change name, I pass in the person, I change the last name, and then I write out in the method what their first and last name is. So I'm making a change to the object itself. And then on line 41, I'm actually going to change the reference. I'm going to change what person points to. So now I'm saying person is a new manager, manager Milder, with a different birth date, making him 31 years old. And I'm going to write out again in the method. So we're going to see what is the person in the method, and then what is the person after the method gets executed. So again, if we look here, you can see we got going into the method, it's Bizarro Matt, 39. And then in the method, it's Bizarro Matt unknown. So we've changed that last name, as you can see there on line 38 in the background. Then we change the reference in the method. So now person is this new manager. That now prints out manager. Coming back out of the method, we're printing out what that other variable points to. Notice it is Bizarro Matt unknown, still 39. So now we've come back out of the method and everything's back where it was. So when we pass that reference type in, by default, the two things to recognize are that last name changed inside the method, but it was still changed when we came out of the method. So that person that we passed in, that reference to an object, was able to be manipulated. The last name was manipulated. When we changed the reference, however, of person to a manager, that didn't persist outside the method. That's only local to the method. Now, if we wanted to change that, we can come up here. We can put the ref keyword in front of there. And we do it on the method as well. And now we're indicating that we want to change that behavior. That if the reference changes, we want to change the object it's pointing to. Got another place where we're using that. So I'm just going to comment that out for now so that we'll get this working and we'll come back to that. So now we run it, Bizarro Matt going in. Inside the method, again, it's Bizarro Matt unknown. After the change in the method, it's manager. And then when we come back out, we still have manager Milner is 31. So by using that ref keyword, we've said, I'm passing you a reference type. If you change the reference in the method, that's going to persist outside of the method. I'm allowing you to change that. Without it, you can only change the object this reference points to, but not the actual reference. To do this, we'll copy. We'll put a comment there. And then we'll paste. As we look at equality and comparing objects, I want to simplify the types that we're going to work with here. I've created 3 different implementations of a point. I've got one that's a class here. The C point has an X and a Y property. I've got an S point for the struct, again, X and a Y property. And then I've got a record point. And notice here I'm using a shortened syntax for defining a record. It almost looks like a constructor, but I'm creating a record called rPoint, and it's going to have properties int X and int Y, as well as a constructor that looks like this signature that takes in the int X and Y. So with those 3 types, we switch over to the program. You can see I've got classes, structs, and records. For each, I'm going to create a point with a value, and then I'm going to assign that point to another variable. So you can see on line 11 and 12 here, create an instance of the class point, P1, and then assign that to P2. And then I compare the equality on line 14. Then I'll create a third point with the same state or same values for its properties as the first one, and then we'll compare 1 to 3. So we do that for the structs, we do that for the records as well. Now you'll notice in the structs, I've commented out these write lines. And if I come back in and put them back, I get the red squiggly, the compiler error that tells me this operator, the 2 equal signs, can't be applied to these structs. So by default, we don't have that equality comparison. Now, if I switch back over here to my types, I'll show you another piece of functionality. I'm actually going to define what that operator should do or how it should behave for my type. So now I've got a public static bool operator and then the actual operator. And I've done both the equality and the inequality here. So we get 2 points passed in. I'm going to go ahead and check that X equals X and Y equals Y on those 2. And for the inequality, that one or the other is not the same. What we'll see for the records and classes is the default behavior of that equality operator. And for the structs, we'll see what we would expect with our equality operator. And it would be the same if we came in here and did P1 equals P2. So that works on our value type as well, and that would do our value comparison. So we're just providing that operator overload or operator syntax to allow us to use this syntax to check the comparison. So if we try this now, again, each follows the same pattern, classes, structs, and records. We have a point, we assign a new variable to that same point, we check the equality, and then we create a new variable with the same state as that first. I'll Control F5 here to run this without debugging. We'll see for classes, P1 equals P2 is true. P1 equals P3 is false. So we see the nature of equality comparisons by default for a class is to compare the references. P1 and P2 point to the same object, therefore they are equal. P1 and P3, despite having the same state, the X and the Y are the same, they don't point to the same object, so it's false. For structs, P1 and P2 equal, P1 and P3 also equal because they have the same state. And for the records, we see that same output. Records follow that value equality by default. So their operator for the equality check or inequality check is value-based, not reference-based. One last thing we could change just to check that is we could take P2 and we could say X equals 10. We'll run that again. And you'll notice P1 and P2 are still true because they still point to the same object. And if I checked P1.x, it would now be 10. We've changed the same object. So they both still point to the same object. That reference check is true. And of course, the second piece, P1 and P3, is still false. So that gives you a little bit of understanding of how the equality works. For reference types, it's reference equality. For value types, structs, and records, it's a value equality. And as you saw, we can change that behavior. So here I created operators for my point, my struct, to support the equality and inequality operators. You could do the same thing. We've seen how to create types and even some derivation and interface implementation. I want to shift to talk about abstract classes. So I've still got my iPerson interface here, but I've simplified it with just first name and last name. And I've got an abstract class called employee. Because it's abstract, I can't create an instance of the employee class, but I'm defining it as a base class for others to implement. So we've got our properties from the interface. We've got a start date that's a property. And then we get into the abstract part here. Now I have properties and I have methods. And if you recall, when we do properties, the get and set, though we often just simplify them like I've done here, actually result in methods. We have a get end date and a set end date method. So those, just like regular methods, can be marked as either virtual or abstract. Now, abstract, as we see here for the process payroll method on line 24, means that this class, the base class, does not define an implementation, but it requires that any derived class does provide that implementation. So process payroll is a method that any class that derives from employee will have to implement. Then we have the terminate method, which is a virtual method. It does have an implementation here. That's a default implementation from the base class. And because it's virtual, that means that a derived class can either override that or can create a new instance. And we'll see the difference with those two. And finally, I've just got isActive as a regular method on here. It's not marked as virtual or abstract, which means I can't override it, but I do have some other options. We look at a derived class like shift worker here. So we've added a shift start time property, and then I have an override of the employee ID property. It's very simple implementation, just returns 1 in the get, but because employee ID was marked as abstract, I have to provide an implementation of that property. The process payroll, you'll remember, was also abstract. So I have to create an implementation of process payroll with the same return type, parameters, and I use the override modifier here to indicate that I'm overriding that from the base class. And you'll notice then the isActive is just that regular method in the base class. And so I've put the new modifier on it because I can't not put a modifier on it, or I have a problem because the base class has an isActive method. And this, while it's just a warning, is telling me you're kind of hiding that. You want to be a little more explicit and say you're defining a new implementation of that method. I could in here call down into the base class because that method's available in the base class. It's accessible to me here, but I'm saying I want to create a new implementation if I have a shift worker. So let's go look at the shift worker in action here. Important note on line 4, my variable is an employee. The object is a shift worker. And we're going to change that up in a bit, but that's important. So I have a shift worker with a name, start date, and shift start time. And then I'm going to call those methods, process payroll, terminate, isActive, so we can see the output. Remember, process payroll was the abstract method that has to be implemented. Terminate was virtual. We didn't implement it in the shift worker. And then the isActive was a regular method that we did provide a new implementation in shift worker. So if we run that, we'll see the output. We see the shift worker payroll. That's what we would expect. But then when we call terminate, employee terminated. Again, we didn't provide an override for that. So it's just using the implementation from the base class. Where it gets a little interesting is when we call isActive, it's calling the employee implementation of isActive, not the shift worker. And that's because that variable is of type employee. If I copy this and I make the variable also a shift worker, that changes things a bit. We still get the payroll from the derived class. We still get the termination from the base class because we don't have an implementation in the derived class. But now, because the variable is the derived class, we see that implementation gets called with our new implementation in that class. I'm going to go ahead and comment this out just to make it a little easier for us to follow along. One last type I'd like to talk about is the notion of a static class. So we've had instance classes with instance state. We can also have static classes. I come out here and add a class. I'm going to call it constants.cs. We've got a bunch of stuff here that we'll clean up a little bit. And I'm not going to make that internal, but I am going to make it static. What's special about a static class? Well, I'm really defining a class that I'm going to be able to use without creating an instance of it. In fact, if I try and put a constructor on here, I'm going to get a warning telling me I can't create instances of a static class. What I can do is make a static constructor. And what that means is when this is first used, when it's first initialized, this constructor will get called. Notice there's no public, private accessors on it. It's going to get called. You can use static constructors on instance classes. So if you want to have some constructor logic that happens and sets some static state, you can use this on regular classes as well. So maybe I have a static field or static state that I want to initialize here. So I might say private static string connection string as an example. Maybe you've got something there. And so you want to initialize that once and have it available. I might be able to do connection string equals server equals that whole bit. And maybe you're loading this from config or you're otherwise getting this and setting it up once. You want to do that. And then for the life of the application, you want to have that constant or that static value set. Another common place where you may use a static class is for actual constants like my class name implies here. So perhaps you're going to use it for a configuration key. So you might say something like public static string. You might do the config, and that might be something like server name equals, and then you could set up whatever that configuration key is. So maybe it's target server. You're going to load the value from there. So the static value is the key that you're going to look up. It's static. It's available now as a string. The other thing you can add is read only, which really just means that we're going to identify this as having to be initialized when we construct this. You could also, instead of static, you can say const string. Maybe we'll do a different one, which is something like database name. And so what's the key for that in our config? Database name. Both of these will work. Because it's a constant, it's treated a little differently. This is something that's going to get optimized by the compiler, may actually impact other libraries if they use this. So use const sparingly for things that you know actually aren't going to change, whereas you can use the read-only static for things that are primarily going to stay the same but may change over time. And of course, for helper methods, you can use statics. So you have a static class. We can't put instance methods on here. So if I tried to come in here and say public int get rating, something like that, I put an implementation on here, return 5. That's going to give me a warning saying you can't have an instance method like this on a static class, but I can have a static. So maybe I'll make this a static method. It's going to return me a date time, and I'll have it called get date time from date only. And then it'll take a date only as a parameter. It's the input. And now I can return something like a new date time, and I'll use that input year, input month, and input day to get me the values I want and return that object. If we go out to our program here to use that static class, constants dot, you'll notice got some IntelliSense here with the stars. But if we look, I have the config DB name and the config server name. The little icons or glyphs are slightly different because one was a const and one's a static field. And I have my get date time from date only and my property. So without having to create an instance of this, I could go in and get the config.db name. That's going to be a string. So string db equals constants